right, you guys, so turn to the yellow sheet. That yellow sheet is what I call a cheat sheet because it has literally every form and every single thing we've learned. Just to review with you guys, we have learned 3 forms: standard form, factored form, vertex form. And in all of these forms, you guys should now be able to go from one form to the other by completing the square or just expanding it or factoring. You should be able to find the x-intercepts, the y-intercepts, the vertex. You should be able to sketch a graph. You should be able to figure out the axis of symmetry and all of that stuff. Now, you know all of this, but you may not know you know all of this. So we're going to do a couple of questions together to help us practice put everything together. I told you guys I'm not going to be here on Thursday. So Thursday's class is going to be like a catch up and review and practice all of this stuff. So if you feel a little overwhelmed with the amount of information, just remember we do have that extra day. Safir? Yeah. I haven't even made it yet. So I have no idea. I know, but you know what? I thought that our class. So I'm not going to go through the sheet with you. However, keep it in front of you. It's a great study tool. Keep it for grade 11. Don't lose it. And you won't have it for your test because it's not open book. But like I said, it's a really, really good way to review everything. Turn to the sheet. Our goal is to try to finish this. Nothing new being learned here. Everything is the same practice as before, but let's just put everything together and see if we understand all of the different concepts. So we have an equation in standard form here. We have something in factored form here. We have something in vertex form here. For every single question, we're going to do all of these different things. The first one is the direction of opening. And in order for us to figure out the direction of opening, we just look at the very first number and the sign that we have for that number. So if the sign is positive, are we opening upwards or downwards? Krishna? Yeah, so in this question, we're going to open upwards. And in this question, we're going to open down because basically the negative sign means our parabola is going to look like this. And there's a negative sign here as well. So our parabola is going to open down. All you need to do is do a quick sketch for yourself. You should know a parabola that opens up is positive and a parabola that opens down has a negative in the first value. You remember that, right? Okay. Also, it's kind of like crappy, but everything we learned last week, because it's a continuation, you do have to remember all of those things. Like you can't completely forget about them, but this will help jog your memory. All right, y-intercept. In order for us to find the y-intercept, we're going to let x equal to 0. That's the only way we know how to find it. So we're going to do that for each one of these 3 equations. If you'd like to work ahead, go ahead and do it, but I'll explain all of them as I do it here. So for the first one, I'm going to put f at 0. And you know what? I realize you guys don't know function notation. So just ignore this f, all this fancy stuff. This is the same as just saying y. So I'm going to say y is equal to 3 times 0 squared plus 24 times 0 plus 36. Because we do this again in grade 11, and that's when we use the f of x stuff, but I shouldn't have put it on, and that's a mistake. This is just going to become 0. This is just going to become 0, and all we're left with is 36. And so therefore, our y-intercept in this question is 0, 36. Easy peasy when it's in standard form. Yep. More quadratics, like word problems and stuff, and then we're going to go to trig. So you guys can see in standard form, figuring out the y-intercept, super easy, right? Let's try it in this form. Again, just change this to a y. It's going to be y is equal to negative 0 plus 4, and then 0 minus 6. We did this last class when we had stuff in factored form and we were trying to figure out the y-intercept. So this is just going to be negative 4 times negative 6, which is going to be 24. All right, for the last one, again, change that h of x to y. Y is equal to I'm trying to find the y-intercept, so I'm letting x equal to 0. So it's going to be -2, 0 minus 2 squared plus 18. What's 0 minus 2? -2. What's -2 squared? 4. So this is going to be 4 plus 18. And then I'm literally just solving. We're not doing anything fancy. I like to call this grade 9 math because that's all we're doing. Just BEDMAS, algebra, and solving. I know the internet's a little bit wonky, so hopefully it'll come up soon. And then this y-intercept is going to be 0, 10. All right, for the x-intercept, we're going to let y equal to 0, and then we're going to solve. There are a couple of ways we can do. So for the first question, I'm going to put a big 0 here, and then I'm going to try and solve this. So it's going to be 0 is equal to, I wish I had a sheet in front of me, 3x squared plus 24x. I think I have an extra one. No, I'm going to take it out. 3x squared plus 24x plus 36. You guys, we did this last class. How do I find the x-intercepts when something's a trinomial like this? Yeah. Yep, you're going to have to factor it. So let's go ahead and factor it. I see there is a greatest common factor of 3. And like I told you guys last class, if you don't remember factoring, go back and review it, watch the videos and do all that stuff, just because there is going to be factoring in this unit and the next one. So when I factor out the 3, I'm left with x squared plus 8x plus 12, which is a nice simple trinomial. What two numbers multiply to give you 12 but add to give you positive 8? Jennifer? Positive 6 and positive 2. Great. Okay. Now think back to yesterday. What do we do now to figure out what each x-intercept is? Safir? Yeah, you take each one of these brackets and you set them equal to 0 and you solve. And you don't really have to show your work for this. If you can kind of see it right away, that's fine. And you guys, this is related to what we did today. Remember how in today's class, I gave you this x-intercept and told you to put it in this form? See how it's opposite? If it's a -6 here, it's a +6. If it's a -2, it's a +2. That's why when I give you the x-intercepts and you put it in this, it's always the opposite. Samir?
Why are you only making, oh, it's y, oh, it's not y equals 0?
Yep, I'm letting y equal 0. Yeah. And then just like yesterday, I put them into this form, which is going to be 6, 0 and -2, 0. By the way, if I gave you something and a trinomial, I asked you to find the x-intercepts and it was not factorable, what would you do? What's your backup? Jenhard? The quadratic formula, which we're going to practice a little bit more tomorrow because I know we didn't really practice it a lot. Perfect review, yes. So if something was not factorable, you would use that formula. Angelique? It is negative. Oh, this one, yeah, sorry, I lost that. Yep, thank you. Okay, great. Let's do the next one. Look at this equation. It is already in factored form. So we have x plus 4 and x minus 6. I let my y equal to 0 already. So do we need to do any math for this? Like rearrange anything? No, everything's already done. We do the same thing that we did before. So we're gonna go x plus 4 is equal to 0. X is equal to -4. And then this one, it's the sorry. When something is in vertex form, unfortunately, it is the most amount of work to find the x-intercepts, and I'll show you why. So we have -2 x minus 2 squared plus 18. And I already set y equal to 0. Now, what we're going to have to do is we're going to have to first change this to standard form and then form, and then we're going to have to factor. So it's the most tedious, most annoying when something's in vertex form to find the x. Okay, so it died. I went ahead and I FOILed it. So I got this, negative 4x plus 4 plus 18. I'm going to keep going and I'm going to distribute the negative 2. So it's going to be negative 2x squared plus 8x minus 8 plus 18. And it's going to be 0 is equal to negative 2x squared plus 8x plus 10. And I'll pause here so you guys can catch up. So, just so we're very clear, this is vertex form. This is standard form. And now we're going to go ahead and factor this and get it into factored form. I know it's a lot of steps, but chances are you're probably going to see this on an assessment because it kind of tests everything. Okay, so if I'm factoring this, I am going to factor out my negative 2. Maybe I'll use orange, which is kind of similar. So I'm going to factor out my greatest common factor. I'm going to get negative 4x minus 5. This is where if you're good at factoring, then this step becomes really easy. I have an x here and an x here. What are two numbers that multiply to give you negative 5, but add or subtract to give you negative 4? Yeah. Close. Close. Yeah. So it's negative 5 plus 1. Exactly. Because negative 5 times positive 1 is negative 5, and negative 5 plus 1 is negative 4. All right, and now I think we've done this enough that we know this is just going to be x is equal to 5. So our point is going to be 5, 0. And this is going to be x is equal to negative 1. So this point is going to be negative 1, 0. And just so we're clear, this is factored form. Okay, so vertex, when something is in standard form, I gave you a couple of helpful hints. We can either change the form to factored form if possible, like if you can factor it, or you can change it to vertex form, which is always possible. And we're going to practice completing the square. So when you change something to factored vertex form, I know it's not very obvious here, but you basically just take these two numbers. Honestly, I can't even read them. I think it's negative 5, change the sign. So this would be like negative 5 over 2, comma, like 33 over 2, maybe? Yeah, something like that. Okay, so let's go ahead and practice completing the square. I know we can factor this because we already factored it in the previous question, and that makes the question easy for us, but we're going to practice completing the square because you do need to know it. So for completing the square, what we're going to do is we're going to group these two terms together. And by the way, completing the square was really well done in the previous test. We're going to factor out the 3. And we're going to see what's left. So it's going to be x squared plus 8x plus 36 all the way at the end. You guys remember what we do next? No? You do remember, Najib. You take the 8 and then what do? Shanahan? Good. So we're going to take the 8. So I'll just go over to the side over here. It's going to be 8 divided by 2, which is 4. And then 4 squared is going to be 16. Okay, so I feel like I'm going to run out of room. Maybe I'll move this question over just a little bit. just so I have a little bit more space. Okay, so now it's going to be y is equal to 3 square bracket x squared plus 8x plus 16 minus 16 plus 36. I factor this and I'm going to end up getting x plus 4, all of it squared, minus 16 plus 36. And then I distribute the 3 to everything. So it's going to be x plus 4 squared. This is going to be minus 48 plus 36. Question, Xavier? Yeah, yeah. Yep, that's fine. And then that's what I get as my final answer. Does this ring a bell? Familiar? Yeah? Okay, good. So why did you say no then, Najib? I know you knew it. And if you don't remember how to complete the square, please review it before tomorrow. I mean, before Friday. Once we get it into this form, what is the vertex? Yep. -4 and -12. Excellent. -4 and -12. Okay. This is actually the last calculations, then the rest of it we just look at. You guys, we can find the vertex from factored form, but it requires a little bit of work. This is all the stuff we did yesterday. So what you're going to do is first you're going to figure out the x-intercepts and take the average of them. Then you take this value and put it back into these x's, and that gives you your y value for your vertex. So let's go ahead and practice doing that. We just figured out our two x-intercepts are going to be -4 and 6. So to figure out the x value, I am just going to take the average of those 2 points. So I'm going to go -4 plus 6 divided by 2, which is going to give me just a 1. You remember doing this yesterday? You take your x value. So this one was like x is equal to -4. This one was x is equal to 6. And then you average them out. So add them up and then divide by 2. Right? It gives you the axis of symmetry and it gives you also the x value of your vertex. To find the y value, we're going to take this number and put it back into the original question. Yeah. When would we need to complete the square? If I give you something in standard form and I ask you to give me the vertex, you could change it to factored form or you can change it to vertex form. What if I just said change the standard form to vertex form? Then you complete the square. Okay. So to find the y value, I'm going to put the 1 into this equation. So it's going to be -1 plus 4 and then 1 minus 6. And I'm going to go ahead and solve this. So it's just going to give me -5 times -5, which is 25. So therefore, our vertex in this question is going to be 1, 25. Okay, and if you missed last day's class, we basically were just practicing how to do that. Practicing, learning, you know. Yeah. Yeah, I just skipped it to save time. All right, for this one, the vertex is you just read this number here and then this number here. So it would just be 2, 18. Okay, how do you figure out the axis of symmetry, guys, when you have the vertex? Which one of these numbers gives you the axis of symmetry? Remember how yesterday we said the x value of the vertex, Arvin? Yeah, so it's whatever the x is. So in this question, it's going to be x is equal to -4 because this is -4. In this question, it's going to be x is equal to 1 because this is a 1. And in this question, it's going to be x is equal to 2. So when you have the vertex, you just look at the x value of your vertex, and that gives you the axis of symmetry. How do we figure out if something's a maximum or a minimum? Well, it's kind of back to this very first one. If it opens up, then it's going to be a minimum. And if it opens down, it's going to be a maximum, right? So this one is going to be a minimum, maximum, maximum. So I'm just going to write minimum, maximum, and maximum. How can I figure out the value of the minimum or maximum? Arvel? Yes, exactly. So in order to figure out the minimum or maximum value, it's just the y coordinate of the vertex. So in this one, it's going to be y is equal to -12. In this one, it's going to be y is equal to 25. And in this one, it's going to be y is equal to 18. So honestly, once you figure out the vertex, the rest of everything else is very straightforward. Okay, last but not least, we're going to sketch our graph. So we're going to take all the information, the x-intercepts, the y-intercepts, the vertex, and all that stuff, and we're going to go ahead and sketch them. Okay, so when we're sketching, here's what we're going to do. I'm going to gather up all the information from everything. So I know my y-intercept is at 0,36. So I'm just going to make a point right here, and this is going to be 36. I also know my x-intercepts are -6 and -2. So approximately this is -2 and this is -6. Because it's a sketch, you don't have to be very, very accurate. And I also know my vertex is at -4, -12. So I'm going to say this is -4 and approximately here it's -12. Okay, so as long as you put down all of those points, and I'm just going to change all of my numbers in black so it's clear. So this is -2, this is -4, this is -6, this is -12, and what was this? This was 36. Okay, now we use all this information to sketch our graph, so it's going to look something like this. Safir? Scroll up to or go to where we calculated the y-intercept at the top of your sheet. See how it says it's 0,36? See up here? The very first box that we calculated, 0,36? Yeah. Yeah. And that's a sketch of our graph. It has our x-intercepts, y-intercepts, vertex, etc. Okay, let's do the same thing for the next graph. For the second graph, my y-intercept was at 0,24. So I'm going to say 24 is approximately there. My x-intercepts are -4 and 6. So let's say -4 is here and 6 is over here. And my vertex is at 1,25. So let's say 1 is here and 25 is here. Although I should put these numbers on the other side. So this is 24 and this is 25. And I think that's all the information we know. So I have an x-intercept here. I have another one over here. My it goes through the y-intercept there and my vertex is there. So putting all of this stuff together, your graph is going to look like this. Does this make sense? Am I going too fast? Are you guys okay? I feel like I'm just taking all the information, putting it on a graph. Yeah, Natisha? 24, see how we over here, we calculated the y-intercept? On the other page, yeah. So I'm taking the y-intercept from here. I'm taking the x-intercepts from here. I'm taking my vertex from here, and I'm putting it all together up here. All right, last question. So 0,10 is my x-intercept or y-intercept. So I'm going to put that here. My x-intercepts are 5, -1. So 5 is like here and -1 is there. And my vertex in this question is 2, 18. So 2 is here. And let's just say 18 is up here. Not the most accurate because 10 would be down here. All right, so I have an x-intercept there and there, a y-intercept there, and my vertex is up here. So this isn't what my graph looks like, although it should be a curve. Okay. I think when I overthink it, it just always looks really bad.